My dear students, class 10, I welcome you to our channel Mind Mapping. Today, we propose to discuss all formulae or formulas of electricity prescribed for your class 10 examination. Let's start. What's electricity? Electricity is simple, the flow of electrons or negative charges through a conductor. Then here is a question, what happens in a dry cell? In a dry cell, some chemical substances are kept, and when connected to a circuit and the circuit is complete, is in on position, the chemical reaction, chemical energy is changed into, is converted into electric energy. So the electrons flow through the conductors, okay, through the conductor connected to the circuit. Okay. So let's discuss the first formula. Formula number 1, that is W is equal to VQ. What's W? The work done due to force and displacement that you have studied in class 9. And V is the force and Q is the charge displaced. Okay, the moment of charge due to the V, that is called potential difference. Then what is potential difference? Let's define. It is the differential electric pressure between two terminals. Okay, so that pressure or that force displaces that charges here, negative charges. Okay, so VQ. So simply VQ implies by transposition or changing the position, V is equal to W by Q. And we can write in means international standard SI unit, that is 1 volt, UB volt, 1 volt is equal to W. W work, the unit of work is joule, 1 joule per 1 coulomb. The SI unit of charge is coulomb, denoted by symbol capital C. So what does it mean? The 1 joule work is done due to flow of 1 coulomb charge, by the force, that is 1 volt. So 1 volt displaces 1 coulomb charge, the work is done 1 joule. This is the simple formula you have to remember, and this has some implication in actually in our heating effect. We shall discuss in next chapter. So come to the second one. So I is equal to Q by T. So what is I? I is the amount of charges, amount of electric charges flow per unit time per second. Okay. So this is the Q is the amount of charge flow, per unit time, Q by T. So we can express in SI unit, that is 1 ampere, because the ampere is the unit of current and coulomb is the unit of charge, that is negative charge, and T is second. So 1 ampere current flows due to the flow of 1 coulomb charge per second. When 1 coulomb charge flows through a conductor per second, so the amount of current is 1 ampere. Okay. So by changing the position by transposition, now you see Q is equal to IT. You remember this one. Okay. Now we got actually two symbols, V and I. V for voltage and I for current. Okay. So this volt is measured by an instrument, it is called voltmeter. And remember, the voltmeter is always connected in parallel between the two terminals for which the potential difference is to be measured. So V denotes the potential difference between the two terminals. Okay, and I is the amount of current, the flow of current, and the amount of current is measured by an instrument that is called ammeter or ampere meter. And this ammeter is always connected in series to a circuit. Okay, this is very important. Now this is over and this is over. Now come to another formula that actually we remember and we know, it is called Ohm's law, and it is very important. We have to apply all these formulae in our subsequent discussion and subsequent calculation or numerical problems. Okay, so simple V is directly proportional to I. The potential difference is directly proportional to current. Okay, so implies V by I is your R. So R is the resistance. R is a constant. R is a constant for a given metallic conductor at a given temperature, at a particular temperature. Okay, and that is the property of that metal, and it also increase, it also changes due to the application of heat. Okay, so R is the constant for a conductor. So this is called a resistance. Resistance means it resists the flow of charges. Okay, so R is the resistance of the conductor. Okay, and it varies from metal to metal. Okay, so from this equation you see V by I is equal to R. So V by I is equal to R implies V is equal to IR. This is very important. We have to apply in our subsequent discussion. V is equal to IR, and simply that implies R is equal to V by I. This is also important, and I is equal to V by R. It is also important. Okay, so let us actually express in SI unit this R is equal to V by I, because we are concerned with V, I and R, because Ohm's law establishes the relationship among three things. One is potential difference V, and another is current, that is I, and another is a resistance. Okay, VIR. Okay, so here R, the resistance, that SI unit of R is ohm, denoted by the symbol omega. Okay, 1 ohm is equal to 1 volt by 1 ampere. Okay, when 1 ampere current flows due to the potential difference between the two terminals of 1 volt, the resistance of the conductor is 1 ohm. Okay, now this is clear. Come to the third is clear. So Ohm's law establishes the relationship among three things: volt, that is potential difference, I current, and resistance. And VI graph is a straight line. Okay, so this is the graphical representation of Ohm's law. You please refer your textbook. Come to point number 4. So this is another application of this Ohm's law. Now you see resistance. Resistance of whom? Resistance of what? Resistance of a conductor. Resistance of a conductor is directly proportional to its length. If length increases, resistance increases. So this is the equation number 1. The condition number 1. The second condition, The R is inversely proportional to the area of cross section of the conductor. So combining together, we find R is equal to R varies L by A. Okay, R varies L by A. So here we have written R varies L by A. Okay, and this implies R is equal to rho L by A. Here rho is a constant. It is called proportionality constant and it depends upon two factors, length and area of cross section. So rho is the proportionality constant, that is called resistivity. Here it is called resistivity and here it is called resistance. You please compare. Now rho is equal to, if you find out rho, so rho is equal to R into A by transposition R A resistance into, that is area of cross section, by length, and this is the formula. Okay. So resistance, you see the unit is ohm, but rho, this is SI unit is ohm meter. That the difference. Okay, and it is the proportionality constant and it is constant for the different metals, different conductors, and proportionality constant, the resistivity also is different for different conductors. Okay, and unit of expression is ohm meter. Here unit is ohm. Okay, and both increases or decreases with temperature. Okay, that we shall discuss. Then come to the formula number 4. Here RS, what does it mean? This is, S means series. When two or more resistors are connected in series, we have to find out the equivalent resistance or the total resistance of 3 or 4 resistors connected in series. What is series connection? So series connection means end to end connection. The positive end is connected to negative end. Negative end is connected to positive end. So end to end connection. Okay. So in series connection, we have, in series connection, please remember the I remains same across each resistor, but V, that is potential difference, that is drawn from the source, is distributed. Okay, so no change of I and no change of current, but voltage drops. So this is an example of your leach light. Okay, so RS implies means the equivalent resistance of 3 resistors. Here we have taken 3 resistors as per a textbook connected in series, and the result is R1 plus R2 plus R3. Okay, let us derive it. Now you see what is RS. Okay, so R is equal to R. Now look at RS. So means here V is distributed. So total potential difference is Vs of resistors connected in series. Let's write Vs. So V is equal to IR. From Ohm's law you see V is equal to IR. Let us apply Ohm's law here. So V1 is equal to I R1, V2 I R2, V2, V3 I R3. So here the Ohm's law, or Ohm's law applied here. Now takes common. Now let us take common I RS from RHS side. So LHS side, RHS. Let us take I common. I is the current. So R1 plus R2 plus R3. So this is cancelled. So now we get RS is equal to R1 plus R2 plus R3. So the equivalent resistance of 3 resistors connected in series denoted by the symbol RS is equal to R1 plus R2 plus R3. So this is about series connection. Now come to the last formula, that is about parallel connection. What happens in parallel connection? V not changed. The potential difference remains same across each resistor. But what happens? I is distributed across each resistor. So let us find out the formula. The formula is 1 by Rp. Rp means resistors in parallel. That is equivalent resistance or total resistance of 3 resistors here. We have taken 3 resistors connected in parallel. Then what's parallel connection? In a parallel connection, you see common com, common point connections. Now you see, so here is the common point, here is the common point. Okay, so all common points of resistors connected to one terminal and other common points connected to other terminal. Okay, so the total resistance, the equivalent resistance denoted by the symbol 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So let's derive. So here I is distributed. So IP is equal to I1 plus I2 plus I3, because this is the total current is distributed across each resistor. I1 plus I2 plus I3. So if we measure, if we take reading, so I1 plus I2 plus I3 will be equal to the total current I. Okay. So you know I is equal to V by R. You see I is equal to V by R here from Ohm's law. So Ohm's law is the base. You see I is equal to V by R. So let's write V by Rp is equal to V by R1 plus V by R2 plus V by R3. So taking common V from LHS side, we get 1 by Rp is equal to let's take common V. This is potential difference V. So V taking common, we get 1 by R1 plus 1 by R2 plus 1 by R3. Now you cancel B on both sides. Now finally you get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But here is a trick. Actually some students, they commit mistake. 1 by Rp is the reciprocal. You have to find out Rp. This is the very important. So RS is very simple, but Rp is in form of its reciprocal. So you have to reverse it. So to find out, Rp means resistors connected, the equivalent resistance of the resistors connected in parallel. This is very important. Now let's solve this problem. So this problem, some students, they have asked me and to calculate this, and this is a problem we have taken from your textbook, and it was also set in your previous year's examination. Okay, simple number of electrons present in 1 coulomb charge. Okay, 1 coulomb, 1C. Okay, so 1 coulomb, it is already written in your book, 1 coulomb charge is equal to 6 into 10 power 18 electrons. Okay. So number of electrons, answer is already given here, but here it is approximately. But actually this question is given in your in-text, in your textbook. So let's find out. And we know 1 electron has or contains 1.6 into 10 power minus 19 negative charges. Okay. Now apply this formula. 1 coulomb charge contains how many charges? How many negative charges? That is number of electrons into number of negative charges. Let number of electrons x or n or a as you like. Let it x number of electrons, and each electron has this number of charges here, negative charges. So x multiplied 1.6 into 10 power minus 19. So our intention is to find out x, means the number of electrons present in 1 coulomb charge. So x is equal to 1 by 1.6 into 10 power minus 19. That is equal to 1 by 1.6 into 1 by 10 power minus 19. So this exponent, this is in exponent form. So we can write 1 by 1.6 into 10 power 19. Okay. So here it is 1.6 means 16 by 10, 1 by 16 by 10, we can write 10 by 16 into 10 power 19, 10 power 19. Now the actually to 10 power 1 into 10 power 19. So that is 10 power 20, 19 plus 1, 20. So 1 into 10 power 20 by 16. So 1 by 16 is 0.0625 into 10 power 20. Okay. Now we have to displace this decimal up to 2 points. So here we multiply 100 means 10 power 2 in the numerator, and the denominator also 10 power 2, no change. So when we multiply 10 power 2 or 100, so decimal point is displaced or moved towards right, that is 6.25, and 10 power 20 by 10 power 2, so 20 minus 2 is 10 power 18. So 6.25 into 10 power 18. But here you see 6 into 10 power 18, it is given in your book, and this is the answer. This is the question, but it is written equivalent or approximately. This is very simple, and this question was asked in your examinations. So these are 6 formulae we discussed, and the rest in our next video. Thank you.